Today in live class, we are going to learn about stars' life cycle. In this class, you will be able to understand different stages of stars. The way we take birth, we go young, we go old, we die. Stars also takes birth. They also go young. We call them adult stars. They also go old. We call them red giants or old giant stars. And hi. Today in live class, we are going to learn about stars' life cycle. In this class, you will be able to understand different stages of stars. The way we take birth, we go young, we go old, we die. Stars also takes birth. They also go young. We call them adult stars. They also go old. We call them red giants or old giant stars. And then they die. There's a process of death, what we call as nova or supernova or maybe hypernova. So stars' life cycle has many stages. Today, I'll try to explain it in simple words during this live session. So let's start with the birthplaces of stars. Nebulas are considered as mother of stars. All the stars have taken birth from nebula. There are different nebula in our galaxy, and they are the homogeneous cloud of hydrogen and helium. You can also call them space clouds. These nebulas are responsible for birth of stars. All the stars takes birth from some kind of nebula. So there are multiple names of nebula, multiple types of these clouds. Some popular nebula from our planet is like Cat's Eye Nebula, Ring Nebula, Eskimo, Hourglass, and these nebulas are very easily visible if with a portable telescope. If you look at Cat's Eye Nebula, it looks like, the eye of a cat. If you look at the Ring Nebula at some angle, at a particular angle, it looks like a 3D gemstone over there. So based on the design pattern in ancient days, we named these names, Cat's Eye Nebula or Ring Nebula or Eskimo Hourglass. So there are hundreds and millions of nebula present in our own galaxy. All of these nebulas are in different shapes, different sizes, and they have all together different names also. Our solar system was born from a nebula called Orion Nebula. If you know what is Orion Belt, it's an Orion constellation in the sky. Near the belt, there is a nebula visible. It's called Orion Nebula. And this is the birthplace of our solar system. Our solar system, that means the sun and all the planets were born inside, they were formed inside the Orion Nebula. And we came like they were done, like they were formed 4.6 billion years ago. So the process of formation ended in 4.6, and the stars, the sun with the planets took birth. If we go further in the detail of these nebula, let's say you get access to a telescope, a space telescope, a very powerful telescope through which you can zoom inside nebula. You get to see this cloud. Now, when you look at this image of nebula, this is like kitchen of our house. We have a fixed and dedicated place to prepare our food. Same way, in one nebula, there are multiple kitchens, multiple places where due to extreme pressure, stars are prepared. So it's not like the entire nebula prepares stars. There are fixed spots in nebula where the stars are prepared, and we call them molecular cloud. They are called molecular cloud, the region of nebula where stars are prepared. When you look inside the molecular cloud, even in this image also, you can see tiny dots. Don't confuse these dots with the baby star. These dots are one step before the baby star. After this, if the star survives, it continues as a baby star. So what do we call this stage as? This stage of a star is called protostar. Protostar, the star which is still yet to form. It's in the process of formation. Some of these stars, roughly 40% of these stars, protostars, will explode before taking birth, and they'll become part of molecular cloud once again. Only 60% of them will be able to come out as a baby star. Although this is a very rational study which was done by European Space Agency somewhere in 2001, the ratio may be different as the study continues. 60-40 is some kind of average calculation we take between protostars and the baby stars. Okay, so when stars are born, it's blue in color. They are blue in color. So when we give example of what do you mean by a newborn star or the first stage of a star, they are blue stars. They are super hot stars. When stars are born with extreme pressure that time, they are actually the hottest stage of the star. Right now, you are looking at the hottest stage of a star, blue star. So whenever in the night sky, you look at a blue star, those blue stars are hot, super hot stars, and they are newborn stars, the first stage of a star. After roughly 4 to 5 billion years, now this depends on the size of a star. In yesterday's live class, I discussed that it's a very simple theory that the stars which are small in size, they tend to have a longer life compared to the stars big in size. So the stars which are large in size, they have a very short span of life. In fact, there are some types of stars which just have a life of 30 million years, whereas the small stars have life of 13 to 14 billion years. So the overall age of a star, overall life of a star depends on its size, majorly on its size. So now we know that the first star, which is born out of nebula, they are blue in color. Roughly, if the star is of average size, after 4 to 4.5 billion years, it will turn into adult star. This is basically cooling of a star from blue stage to yellow stage. Now the star is young. Yellow color star means young star. It means adult star. Now the star is young. Yellow stars are the adult stars which are average in temperature. So they are cooler than the previous one. And obviously there is a scope of cooling further. And this is a young star. All the yellow stars are termed as adult stars. Further to this, star turns into red color. Obviously, students, it's not like a LED bulb which changes from blue to yellow and then red. It's a slow process. So blue turns into a light blue, then slightly towards white, then light cream and yellow, then orange, and then red. Right now, you are looking at the last stage of a star. This is the last stage of a star. After this, star is dead. But one magic happens over here. When a star turns from yellow to red, it expands up to 300 times. When a star turns from yellow to red, it expands up to 300 times. Now, when sun will turn from yellow towards orange and red, it will also expand up to 300 times, may consume Mercury, Venus, maybe Earth also. That will happen after 5 billion years. So till now, we have seen 3 stages of stars here. The baby stars, blue in color. The adult stars, yellow in color. And red stars are actually the old stars. After this, there's explosion in stars, which actually kills it. And that is what we call as supernova. Sun may not turn into supernova because it's not that big star. If you want to know the reality here, sun is smaller than average mass and average size of a star. Sun is smaller than, it's below average size star, below average in mass also. The best part is life is only possible in, it's actually more, the possibility is really high in the stars like sun. If the stars are big, they'll have a very short span of life. If the star only survives only for, let's say, 30 million years or a billion year, in 1 billion year, how could life evolve? How could planets be formed properly? So the stars which are small, they tend to live longer and give chances to the planets and may have a planet inhabitable zone with life like us. So when a star dies, the death process, the explosion, is called supernova. Average stars, or slightly above than average, they turn into supernova. What is not common? The normal nova or hypernova. These are very rare. Hypernova means extremely high massive stars explosion, hypernova. A lot of radiation comes out. After this stage, small stars, after the explosion happened, either nova, supernova, or hypernova, small stars turns into white dwarf. Small stars turns into white dwarf after this stage. So star is dead, and the dead star turns into a white dwarf. The massive stars turns into black hole. This answers the biggest question in astronomy, one of the biggest questions in astronomy, that how black holes are formed. Now listen very carefully. We are talking about a theory which is called Chandrasekhar's limit. Chandrasekhar's limit says if any star is 1.4 times more massive than sun, if any star is 1.4 times more massive than sun, will become a black hole, will turn into black hole after its death. But if it is less than 1.4 times of mass of the sun, it will turn into white dwarf. In detail, we will study about black holes, white dwarfs in our upcoming live sessions. Today, I would like to take you further with some examples of black hole, some introductory part of the black hole. So the massive stars, the stars which are 1.4 times more massive than sun, they turn into black hole. Right now, you're looking at the first picture of black hole we have ever captured. There is a limitation in capturing the picture of black holes as it absorbs the light also. So whenever you actually try to click any picture, it absorbs the light. It's so powerful that nothing can come out of a black hole. Nothing can come out of a black hole. Black holes are so powerful that even time slows down. On Earth, if you want to stretch 1 second into 1 hour, you can't do that. Can you stretch 1 second into 1 hour or 1 hour into 1 day? We cannot do that. That's impossible. In black hole, when you walk inside, you may realize time is slow for you. You may have spent only 15 minutes walking inside, but on Earth, few hundred years would have passed. Now, that's a very fictional example. We may not survive inside a black hole, but if we can survive, actually time slows down. It's also said that when we reach the center of the black hole, time stops. Maybe about black hole in our upcoming classes, we'll discuss in detail. So now this is one example how big black holes can be. There's a black hole called Phoenix cluster. And you can look at compare the size of solar system with the Phoenix cluster. Solar system is just like a dot, right? Thousands of solar system can fit into this Phoenix cluster. And this is not the largest black hole. There are many large black holes which are even larger than Phoenix cluster. Okay, so most of us misunderstand black hole as, that it's like a vacuum cleaner, keeps on sucking everything which goes close to it. That's wrong. Black holes are like absorbing cloth, super absorbing cloth. Mostly in our kitchen, we use the absorbing cloth where you if there's a water spill off, you put the cloth and that cloth absorbs the water. Black holes are that. One question got very popular during 2021 on Quora that what will happen if you replace sun with black hole? A lot of people started sharing the idea we will fall into it, the earth will be stretched into a hyperloop and got sucked into the black hole, blah blah. Not many comments were there, which this is what I read, and there were some good answers also at the same time. So I'm sharing you the correct answer for this question. What will happen if sun is replaced by a black hole? In that case, black hole is not always in attack mode that it will keep on eating Mercury, Venus, Earth, Mars, Jupiter, every planet. Slowly, gradually, obviously, there will be a change in orbit. Slowly, gradually, there will be a change in orbit of all the planets, in fact, nearby star also. But humans or life on this planet will die because of cold instead of falling into a black hole, because that's a very slow process. We will die out of cold. We just don't get light from the sun. We also get heat from the sun. And because of that, the temperature is maintained below atmosphere. As I discussed in the yesterday's class, that in space, if we go without a proper protection of spacesuit or cylinders or any new spacesuit design which is there in the market now, which astronauts use these days, we can survive only for 2 minutes without that. So like I'm wearing a t-shirt right now, I go with this in the space, I can survive only for 2 minutes. Our human body is not designed for space. And on Earth, without sun, will die. Will die out of cold. So let's revise all the small points of this today's session of stars life cycle. Today, we tried to understand in our live session about stars life cycle. As I told you, stars take birth from nebula. So nebulas can be considered as the mother of stars. You have to excuse me for these words like mother or baby star or so. But I think that makes the subject easy to remember and understand the process. So I use these terms. So it's not, obviously, it's not a scientific. There is no classification of a star which is called as a baby star. But when I say baby star, I am sure that you understood we are talking about the initial stage of a star. Most of my students are young kids. So the entire content or the live lessons which I took previously, which I'm going to take in future, all are designed for young kids so that they can understand it. The purpose is to understand the topic. So the stars takes birth from nebula. And there are many types of nebulas in the sky, like Cat's Eye, Eskimo, and so many others. And they're very easily visible with good telescope. It may be difficult to observe some nebulas from city light pollution, but if you move to hill stations, if you go for a vacation to some forest regions or so, you can carry a small telescope or astronomical binoculars, and you can observe these nebula. Then if you zoom inside the nebula, you get to see the molecular cloud. This is like the kitchen of nebula where stars are prepared. So all the tiny, tiny dots you are seeing right now, they are not baby stars. This stage of a star, we call it protostars. Now, once the stars are born, they are blue in color. This is as a baby star. Now, they are very hot in temperature. Then after 4.5, 4.6 billion years, depending on the size, they cool down into yellow. They further cool down into red. If I give you an idea, blue stars are the hottest. 35,000 degrees Celsius could be its average temperature. Then somewhere around it drops down up to 7,000 degrees Celsius. Further, it drops down to the coolest stage, 2,000 to 2,500 degrees Celsius. Now, it's coolest stage of a star. That doesn't mean you can go and play football over there. It's still 2000 degrees Celsius hot. Okay. Then the explosion happens. This process, we call it supernova, nova, hypernova, based on the intensity. Now, the small stars turns into white dwarf. We will study one day about white dwarf. And the massive stars, which are 1.4 times more massive than sun, turns into black hole. 1.4 times more massive than sun. That means even the sun will turn into white dwarf, not a black hole. It's an average, below average star. This is the first picture of a black hole captured. And this is the size of one black hole. This is not the largest black hole. Phoenix cluster is larger than average. And if you compare with the larger than average size of a black hole with the solar system, you can see how many solar systems can fit into it. The black holes are not like a vacuum cleaner. They mostly absorb the nearby matter and energy. One question, if you are listening to it till now, the question is, you have to answer in the comment. The question is, how many black holes are present in our Milky Way galaxy? If you know the answer, if you find the answer, share in the comment. I'll tell you the correct answer in the next session tomorrow, same time, 9 p.m. Take care. Bye-bye.